Let's talk about one of the most prominent features on our faces, but one we probably don't think about all that much in evolutionary terms: our nose. Well, it turns out its shape tells this incredible story about our ancestors' journey across the planet, and it's a story all about the fundamental physics of the air they had to breathe.
I mean, really think about it. It's such a simple question, right? But the answer is this brilliant case study in human evolution. You see, the incredible diversity we see in noses isn't just some random chance. It's basically a record of adaptation etched right onto our faces over thousands and thousands of years.
And this isn't just a casual observation either. We've got the data to prove it. This chart is fascinating. It shows a really clear pattern. If we look at the average width of the nares, that's just the scientific term for your nostrils, we see these significant differences across populations whose ancestors evolved in different parts of the world. So what's driving this? Well, the answer starts with understanding what your nose actually does.
Okay, so let's get into it. First things first, we need to stop thinking of the nose as just a feature on our face and start seeing it for what it truly is: a high-performance piece of biological engineering.
Yep, that's right. Its main job isn't just smelling, it's acting as this perfect self-regulating HVAC system, heating, ventilation, and air conditioning for the most sensitive organs in your body, your lungs. Every single breath you take gets processed first.
So the secret sauce to all this efficiency, it lies deep inside your nasal cavity. These incredible structures, the nasal conchae, are amazing. They're like these little biological radiators, creating a huge, warm, and moist surface area that's packed into a super tiny space. This whole setup makes sure that the air you breathe is completely transformed before it goes any further.
And it performs three absolutely critical tasks on that air. First, the sticky mucus lining traps all the junk, dust, germs, you name it. Then, as the air tumbles over those conchae, it goes through this massive thermodynamic shift. It gets heated up, and crucially, it gets humidified, totally saturated with moisture.
And the efficiency is just staggering. Get this, a full 90% of this whole air conditioning job is done before the air even gets past your nasal cavity. It's an incredibly fast and effective process. So, the big question is, why? Why is this so important?
So, what is this amazing system protecting us from? To get that, we need to meet the environmental villain of our story. This whole sophisticated system evolved to fight a very, very specific threat.
Well, the answer lies in the fundamental laws of physical chemistry and the super delicate environment that exists deep inside our lungs.
Just look at this contrast. Your lungs need air at a very stable 37 degrees Celsius with 100% humidity to work properly. But in colder climates, the air is much, much drier. That's a basic law of physics. Colder air has a lower capacity to hold water vapor. Its partial pressure of water is just extremely low, and that creates a massive thermodynamic challenge for our bodies.
Breathing that cold, dry air directly would be, well, catastrophic. It would chill the delicate lung tissue, and even more critically, it would cause water to just rapidly evaporate from your airways. And as this quote from the research makes clear, that dehydration damages your lungs' ability to clear out pathogens, leaving you wide open to infection.
Okay, so we've got the function of the nose, and we've got the threat from the environment. Now for the big reveal. Let's connect all of this back to those different nose shapes we saw at the very beginning. You see, the differences in our noses, they aren't just cosmetic. They are a living legacy of natural selection at work, shaping our anatomy to best handle the local climate our ancestors had to survive in. And wow, the pattern is just crystal clear. This chart nails the core finding. In warm, humid climates, where the air is already pretty close to what the lungs need, wider nostrils are really common. But in cold, dry climates, narrower nostrils completely dominate.
This is it. This is the big aha moment of the whole story. The shape of the human nose seems to be a direct evolutionary response to temperature and humidity. So the final piece of the puzzle is how? How does a narrower nose actually help? And this is where the physics gives us the answer. By forcing that cold, dry air through a narrower passage, you actually create more turbulence. Think of it like a swirling, chaotic river instead of a slow, straight one.
This churning action forces more of the air to come into contact with the warm, moist walls of your nasal cavity for a longer period of time. It's a simple change in shape that dramatically boosts the transfer of heat and moisture. It's brilliant. But you know, as with all good science, the story might be even more complex than that. So let's explore one more really intriguing possibility.
So, while the climate adaptation theory is incredibly strong, it might not be the whole picture. There's another fascinating hypothesis out there that suggests the external nose evolved to separate our nostrils, giving us something called stereo-olfaction. How cool is that? This could have helped our highly mobile ancestors navigate huge distances by detecting tiny differences in scent trails. Kind of like how having 2 ears helps us locate a sound.
So, what's the big takeaway here? Well, the incredible variety we see in human noses is definitely not random. It is a powerful signal of evolution in action. The evidence points overwhelmingly to climate as a major driving force, shaping our ancestors' noses to give them a survival advantage. And narrower nostrils seem to be a brilliant adaptation for conditioning that harsh, cold, dry air. In short, our faces carry the map of our ancestral migrations. It's just a compelling reminder that every single part of us, right down to the shape of our nose, is a chapter in the epic story of human survival. It kind of makes you look at your own face a little differently, doesn't it?